Yes, NOAA operates two series of satellites. One is the geostationary satellites, and another series is the polar orbiting. And at any time, there's two geostationary and 3 polar orbiting operational satellites in operation 24 hours a day, 7 days a week. Yeah.
And so do they keep track of polar caps as well during their orbits? So you have data on polar ice caps and other areas of Greenland, for example?
Yeah, the geostationary satellites that NOAA operates generally cover the U.S. and adjacent ocean areas, and then the polar orbiting satellites do give us data over both poles. Mm-hmm. So yeah, we can monitor things like the polar ice caps and higher latitude phenomenon.
Mm-hmm. And have you noticed any significant trends in terms of the polar caps over the last 5 to 10 years, or does it really vary?
Yeah, I mean, I think that depends on which type of instruments you're looking at. For instance, NASA flies similar satellites, and there's different types of measurements that are made, and so we have there's about 30 to 40 years worth of data from several different satellite missions, and I guess the challenge is to piece all that information together to make it a coherent set of records. And so depending on how that's done, you can get these different sorts of trends in the data. So some satellites are showing that there's been a decrease in the amount of ice in the, say, the North Pole. Mm-hmm. Lately.
And is the same true for the South Pole, or you're not sure?
I'm not that familiar with what's going on in the Southern Hemisphere. I think there are some trends, but they're probably a little less dramatic than what's been seen in the, yeah. Well, remote sensing is the science of taking measurements with other instruments. Okay, so satellites is one form of that. Radars could be another form of remote sensing. And probably the most important thing is getting measurements in areas of the world that we have no ground measurements. Okay, so the Earth is roughly 2/3 ocean, so obviously having satellite coverage over the ocean is one of the few sources of information we could get. Same thing would be true for, say, radars, getting information, say, on rainfall over areas where we don't have any people taking measurements.
Okay. And does that supplement like buoy information as well that NOAA maintains that? Or?
Yeah, a lot of the trends in the products we generate, or we try to merge all that information together to make the most accurate set of products that we have for, say, sea surface temperature or air temperature.
Mm-hmm. And tell me a little bit about how you use remote sensing in particular. What is your focus area in terms of your research?
Sure. The work I'm involved with, I've worked mostly with instruments that measure Earth information in microwave frequencies. Microwaves have an advantage over, say, the visible infrared because we can see through clouds, so we can sort of get an all-weather capability. And so I've been working on things like global precipitation using satellites for, say, the last 20 years or so. That's probably the most reliable record that we have with the microwave data. So then again, we're trying to take that information along with surface reports of rainfall and try and make a global climatology of rainfall. And then if we can make that accurate enough, we can start looking for changes in the patterns of rainfall over time.